In this video, we're going to be talking about XML, the extensible markup language. We're going to be going over a new example, not covered in the slides yet, that goes from data all the way to an XML document. This tutorial is then continued in the XML schema tutorial, which we then take that XML document that we're going to be making in this video and then extending it with a XML schema. Before starting in on this video, there's a few required readings that you should cover first. These can be found on your OWL course site, and they include the XML tutorial slides and the XSD or XML schema tutorial slides. They're going to give you a little bit of background on XML, some of the theory, and in this video we're going to put that into practice with an example. Additionally, there's also the W3 school tutorials for XML and XSD. These are optional resources. They cover a lot on XML. They also go over some of the things that we're already going to learn in those slides and in this video. We highly recommend that you look at them, but they are optional because we do cover everything you need to know in the slides and this video. But if you're feeling you're struggling at all or you want any extra practice with XML, these W3 school tutorials do provide some interactive quizzes as well as interactive tools for helping you learn the material. If you're struggling at all with XML, we highly recommend that you take a look at those W3 school tutorials in addition to all the required material. So let's get started with a quick review on XML. So you should read the XML tutorial slides because that gives you far more details, but we'll go over some of the basics in this video. First, the problem that XML is trying to address. So we need a way to store and transmit data in a standardized way. So we have databases, relational databases we've already seen with MS Access for the storage side of things, but we need sort of a standardized way to transmit data between different systems. If everyone made their own format, then we'd have problems because there wouldn't be compatibility between the different programs. It'd also be nice if we had a way for it to be both readable by humans, so we can understand it when we look at that data, as well as understandable by computers, so they can process it easily. Computers aren't quite that great at natural language processing yet. That's still a big research topic. So simply having data just in like you would write in an email won't be very good for a computer. Having the data in raw binary code that a computer could read would be great for computers, but it's not going to be great for humans to read, edit, or create. So the idea is we need a solution that's going to be able to allow us to transmit data from computer to computer, as well as transmit into different formats. So we might have it in a text file. We need to be able to transmit that into different software. For example, we might want to be going from text to a relational database like Microsoft Access. So XML, the extensible markup language, is a solution for this that's quite popular. It provides a few things. It's human readable and it's machine readable, so we can read it and the computer can understand it. It's also standardized, so there's a standard format, and it's an open standard, so everyone's able to use it and read the documentation on it for free. So extensible and flexible. That means it can be used for many different use cases, and you can even extend it to create and expand on your own use cases. We'll see how that works when we get into the schemas. So that's great, but what does XML actually do? Well, not much, on its own at least. So XML is only used to store and transmit data. It's not computer code, it's not a programming language that you can run or compile. It's also not HTML, even though it looks a lot like it, that encodes display data. All it is a way to structure data so we can send it from one system to another. So I have a few real-world use cases listed here. A big one of those is web services, especially in cloud computing. A lot of times when you're going to be communicating with those services and transmitting data to them, it's going to be through some kind of XML document or some protocol involving XML. Another big area is electronic health records. I have a few of the standards listed here, HL7, and they also have HL7 CCR and CCD documents. So these are people's health records that have been turned into electronic format as an XML document. It's also very big in access control, especially in access control research right now. And that's mostly centered around encoding policies of organizations into a standardized document that can then be used to make access control decisions about. It's also used in things like financial record keeping, human resources, and many, many other places. So here we can finally see what one of these documents look like. And if you've been reading the XML slides, this example should be familiar for you. This is that example where we're encoding a list of friends and their hobbies in an XML document. In this case, we're only showing one record in that XML document. It's for Billy here. There are a number of rules all XML documents have to follow, and these are expanded on a bit more in those XML slides. So the first rule is that everything has to be a tag or data. Second rule is tags are case sensitive and must follow the naming conventions or the naming rules. So what do we mean by case sensitive? So that means, if we were to look at this example again, if we had the word friends as a tag, which we can see at the top there, and we had another tag called friends, it would be a different tag if it used capitals or if it didn't use capitals. So by that, we mean that capitalization matters in XML tags. So tag is not the same if the capitalization is different. And by naming rules and naming conventions, XML has a few rules that we'll get into later in this tutorial about what you can and cannot use as a XML tag name. For example, spaces aren't allowed in XML tag names. So every tag must have a start tag and an end tag. So we can't have any tags that are not closed, and we can't have any end tags that aren't matched with the start tag. So whenever we see a start tag, you also have to find a matching end tag in the document. And these tags have structure, and we can't have overlapping tags. So everything has to be properly nested. And we'll take a look at that soon too. And XML documents are only allowed to have one root element, one root tag. Let's take a look at this and sort of break down what each piece is. So in the yellow here are what we call tags. These are always surrounded by these sort of brackets that look like greater than and less than signs, and they denote sort of metadata that describes the data that they contain. So the computer doesn't really care about how these are named. That's more for the humans reading the file. For the computer, it's just sort of structuring the data and sort of differentiating it. Here's the actual data that this document contains. One thing you might notice here is there's quite a lot of metadata compared to data. So XML is great for being human readable and computer readable, but that comes at a cost. And that cost is that these files are going to be a lot bigger because we have to encode all this extra metadata basically for the humans. So next thing we see here in the blue are what we call the start tags. These are sort of like opening up a new area in the document. So each one of these has to be matched with an ending tag. You can see those here. So if we look at the top, we have a friends tag, that's the start tag, and at the very bottom of the document, we can see right here, we have what we call the ending tag, or the closing tag. These are always denoted with that /. So every time we see a tag in the XML document, except for a few special cases that we'll get into, there has to be a matching end tag. So we can see that we have a person's tag here, and it's matched by a closing end tag down here. We have an open name tag here, a starting tag, and it's matched by a closing name tag here. What we mean by tags can't be overlapping means that we can't have these out of order. So we couldn't have like name here, followed by age, and then end name, and then end age, because that would be overlapping. So each one has to have a distinct area. Tags can contain other tags, like we see here, but they can't be overlapping, crossing each other's boundaries. So this is one of those special cases at the top. This is a preprocessor command. And all this really does is it tells the computer that this is an XML document and what version of XML we're using. So you'll see here that it says version 1.0. In almost all cases that you'll see, we'll be using version 1.0. And most cases you'll be seeing in real life will also be version 1.0. There is a version 1.1 of XML, but it's a very special case, and it just adds a few features that were just used for a few obscure systems. It's also a bit of a misnomer to call it 1.1 because the 1.0 standard has actually been updated more recently than the 1.1 standard. So for everything we'll be doing in this course, and probably everything you'll ever encountered in real life until the standard's updated again, you're going to be using version 1.0. So every XML document you create must have this at the very first line. There can't be any spaces in front of it, can't be any line breaks in front of it. It has to start with XML version equals 1.0. And this is one of those special cases where it doesn't have a clear closing tag. Those are the preprocessor commands, and they're called that because they're sort of read and processed before the rest of the document. So the computer sort of throws out these lines once it understands them. So in this case, it's just saying this is an XML document. So friends here is what we call a complex element. There's two main types of elements to worry about in XML. Complex elements, like friends here, and simple elements. So complex elements are called complex because they contain other elements. So we can see here that the friends element between the start of the tag and the end of the tag down here contains a number of other tags. So we have the person element, we have the name element, we have the age element, we have hobbies, and we have the closing for person. So because friends contains other elements, we call it a complex tag. This would be everything that the friends tag contains.
In the opening person tag, you will see that it has a little special feature here. See the text that says order equals 1 inside the tag. This is what we call an attribute, though you may also see them referred to as arguments in some sources. This is another way of encoding data. The best practice is to only use attributes to encode metadata. That would be the data about other data. In the example that we see right now, this attribute would represent the order of the person in your list of friends. Another example might be using an attribute to store the unit a value is in. For example, let's say we're storing a weight of some sort. You might use a unit attribute on that element to define the unit this value is in. So for a weight, that might be kilograms, for example. So best practices here are to only use attributes for metadata, and to use simple elements to store regular data. It would be a bad idea, for example, to create a name attribute for storing a person's name rather than using a simple element.
So for Billy here, that's a simple element, and that's an element that only contains data. So simple elements are anything that only contains data and no other tags. In this case, the name tag has Billy in it, and only Billy, so that's just raw data. So that would be a simple element. So we would say that name is a simple element. Age is the same way, it only contains 31, so that's a simple element. Hobbies, however, contains 2 hobbies. So that is going to be a complex element, because it has tags inside of it. If it were to say, for example, just Avengers, D&D, and it didn't have any extra tags, that would be a simple element, because it would just contain data. So if you ever see any of these tags, any of these greater than less signs, that means that this is probably a complex element. So this distinction between simple elements and complex elements may seem a bit trivial now, but it's going to become important when we get to XML schemas. Hobby in this case would be a simple element, because both of these only contain data. So even though that hobby is repeated twice here, we still say that there's only one hobby element. When we're talking about elements, we're referring to the name of the tag here. So this would be both hobby elements. So there'd be 2 instances of the hobby element in this case. And hobby would be a simple element because it only ever contains data. Now we're going to get into a new example of going from data to XML. And we're going to be reusing that doctor's office example that we've seen in the previous weeks. So if you remember from previous weeks, we had a scenario with the doctor's office where doctors were assigned to nurses and doctors were able to order tests. So in this example, we wanted to take this, we assume that we already have this database made for our doctors and nurses, but now we want to be able to import patients into our database. So doctors presumably have a number of patients each, and we're going to assume that they all have some amount of medications that they're currently prescribed. So we want to create an XML document for being able to import this into Microsoft Access eventually. We're going to need 2 things. In this tutorial, we're going to be working on creating that XML document for patients. And in the next tutorial, we're going to be working on creating a schema to validate that XML document. So here we see the raw data. In this case, we have 3 patients, and we're going to be looking at this data a bit closer. If you're interested in getting a copy of this, it should be the patient.pdf file on OWL, and I do recommend that you use it to follow along with this tutorial. So I recommend that as you're watching this video, you pause at each step, try to do the problem yourself. If you get stuck, or if you think you've completed that step, unpause the video and see if your answers line up with mine. So the first step we're going to do is breaking down the data. And the first thing to do that is we have to understand the data. So what we have in front of us are 3 patient records for the doctor's office, and we can see that there's a lot of repeating data here. So the first most obvious thing is that we have 3 patients repeating, but let's take a look at each one of these sort of fields inside this data. We have a unique health card number. The fact that it's unique is going to be important later, but this would just be like the Ontario health card record. We have a patient name. We have a patient phone number, but it's important to note here that not all the patients have phone numbers. So one of the patients here doesn't have a phone number. So we can assume that this field is going to be optional. We have patient addresses, and we have physician IDs. So these would be the doctor IDs from our doctor office example database. So it'd be this doctor ID field from the database. In our case, we know that all these IDs are valid, and they're from our doctor's office example database. The next big thing is a medication list, and this has a little bit more complex data in it. First, we have the date this list was last updated. We have the names of the medications. We have the dosage of the medication, and in our case, we're going to assume that it's always in milligrams. We have instructions for taking the medicine, so that could be things like daily, twice daily, with meals, as needed, things like that. We have the number of days, so this would be the course of the medication, how long they're going to be taking it for, and then we can assume in this case that this is always going to be in days. So we have the patient's birth date as the last field. You can see that in this case, a lot of this data is repeating, and we're going to be taking advantage of that when we make our XML document. So the next step is going to be to remove all the unneeded information. So you can see there's a lot of things like it says physician, health card number. We have things like milligrams, days. A lot of this isn't actually data. It's sort of more describing the data. So we want to remove most of that. That would look something like this after we delete everything. You will notice that I do have one that I left in the data for, and that's because this is going to be a bit of a special case that we're going to deal with later. So for now, we're going to leave it how it is. So other than that special case and a few commas, all the unneeded stuff has been removed, and all we have is our raw data. You will notice that for the medications, we do have a few different data elements on the same line. So the next step is going to be knocking all of those onto each line. So every element of data, every part of the data is on its own line. And right now, we're just looking at one patient record, just for space reasons, because it would be hard to show the whole record all at once. What we see on the screen now is one patient record with absolutely all data elements put onto their own line. The next big step is going to be grouping the data. And this is probably going to be the biggest task when making your XML document. And to help us out a little bit, I indented the data a little bit, so all the medications are together and all the things in the medication list are indented. So the first group we're going to identify is the patient itself. Right here, we can see that arrow on the left, the red arrow. This denotes a grouping. So the first grouping is patient. Second grouping is going to be the medication list. Third grouping is each individual medication. So what we're doing here is we're trying to see there's sort of repeating data in our raw data. We want to sort of find the repeating data and put it into groups. So we had 3 patients, so we're going to identify that as one. And we have an area where we have a patient medication list, so we identified that as a grouping. And we identified those repeating medications, so that's also a grouping. Grouping would be like a collection of data, where eventually we're going to be what's going to become our complex elements. Well, the things that we don't want in groups are individual data elements, sort of like the name Joe Blogs or his phone number. Those wouldn't be groupings because they don't really contain other data. They just have one single thing in them. But there's still one group missing here. And to see that, we're going to have to zoom out a little bit so we can see the other patient records. If we zoom out a bit, we can see the 3 patient records here, and we can see how one grouping in red for patients occurs 3 times because there's 3 patients. So there should be one more sort of root grouping, and that's what contains absolutely everything. Remember, all XML documents need a root element or a root group, and this is a group that contains everything. So in this case, that would be the list of all the patients. So we're going to zoom back in. And in this case, the next step is going to be naming these groups. So after we've found all the groups in our data, we need to give each one a name. and it should be a descriptive name. So XML allows you to name your tags almost anything within the rules, and it would work fine for importing it into a database or transmitting it between systems, because the computer doesn't really care about what the names are. But we also want our XML document to be human readable. We want to be able to understand it when we come back to it. So all the names we use should be descriptive. And in your assignment or on an exam, if you're writing any XML, make sure that you are using names that are descriptive of the data. Don't just use gibberish. So there are a few rules for naming things, as I alluded to before. And we have to follow these rules for it to be valid XML. And we also have to follow these rules to make it a bit easier on us when we import it into Microsoft Access. So the first big rule is every group and every data element is going to need a unique name. So we can't reuse names. The next thing is that it has to obey the XML naming conventions. So those conventions are things like we can't have spaces. So we couldn't have friends, a space, and then the word list. That wouldn't be allowed. There's no white space allowed in our element names. And as I said before, it's case sensitive. So you see I wrote name 3 different ways here, one with a capital N at the beginning, one with no capitalization, and one with a capital A and E. So all of those would be considered different groups. So the capitalization matters. If you have different capitals, it's a different name. That means it's a different group, and it'll eventually be a different element in your XML document. So names cannot begin with a number. So we couldn't have like the number 1 and then friends list. That wouldn't be allowed. We're allowed to have numbers in our tags. They just can't be at the beginning. So we could have them midway through. So we could have like NA1ME. That'd be allowed. Or we could have name 1. That'd be allowed. But we couldn't have one name unless we spelled it out with letters. There's a lot of restrictions on punctuation. So the only punctuation you're allowed to use in a group name or eventually an element name is going to be the underscore symbol and the period. Anything else is not allowed. And our groups and our elements cannot start with the word XML. So you couldn't say XML name. That wouldn't be allowed. You could say name XML because it doesn't start with XML, but no groups are allowed to say the word XML. So the next set of rules, they're not part of XML. They're just going to be rules that we should follow to make sure that we get our document into Access okay. And part of the problem with that is Access has a few reserved words. We talked about this a little bit in the Microsoft Access tutorial, like we shouldn't name a field the word name because that's a reserved word. And a lot of these things, these groups, these XML elements, are going to become fields and properties inside our Access database. So we don't want to use any Microsoft Access reserved words. So I have a few listed here. Some important ones are things like name, note, move, date, type, sum. So we shouldn't use any of them on this list. So if you want the full list, I do have a link here, but I have most of the ones you'll probably run into listed there. Big ones are going to be name and note. So let's start going through and naming these groups. So first we have medication and medications. So medications with an S is going to be our medication list, and medication is going to be the actual medication in that list. So note that I repeat the word medication 3 times here. That's fine because those are each considered to be the same group. So each group has to have a unique name, but not each instance of that group. By an instance, we mean that that group would contain the same kind of data. So each medication here has medication name, it has medication dosage, it has instructions, and it has the number of days that's taken. So that's what we're considering a medication group. The medications group with an S is the whole list itself. So some people don't like doing that where you have an S on one and not an S on the other because it's easy to misread, it's easy to make typos. So one thing you might want to do instead of calling it medications is to call it medication list or something like that. There's no hard rules on that, it's mostly up to you. So the next one we're going to call patient, and that's going to be the grouping that contains the whole record for a patient. And then the big grouping that contains all the patients is going to be called patient list. So the next step is going to be naming the data elements. So we name the groups. Now we want to name each piece of data. And they follow the same naming rules as groups. So we'll start by calling that health card number card num. We can call it whatever we want. One standard that a lot of people use is called camel case, and that's where you have 2 words together without a space, and you capitalize each letter of the word. That's not a strict rule. You can use whatever kind of naming convention you like, but usually the best thing is to keep it standard. So if you do that, where you start each word with a new capital letter, then keep that consistent for your XML document. The big thing with naming conventions is more consistency than which one you follow. It's good that you have one rather than which one specifically. We'll call patient name just name for now. We'll call phone number phone number. We'll call the address address, doctor ID, and we'll just keep going on. This is going to be last update. We'll call that name for medication name, dosage, note, days, and all the other ones have to be the same. So in this case, this is another medication group, so we have to use the same names. So if it's in the same group, it should have the same data element names. Really, we don't even really have to individually assign names if a group's repeated, because once we've done it for one group, we're done. We don't have to keep going and rename the same thing. And there's birth date at the end there. It's important to note that that birth date at the end there isn't in the medication list. It's in that patient record. It just happens after. So we are allowed to have like lists in the middle of our data. They can be in whatever order you like, but the order usually is important. So if we're going to set up our file with the birth date at the end, it always has to come at the end. So one question, you can pause the video and see if you can answer this. Are these data element names that I've added on the left here in blue valid? Do they follow the rules? So pause the video, take a look at them, see which ones you think are valid, and maybe some aren't. So the first one is note. So there's a problem with this, and that's because it conflicts with an access reserved word. I showed you that list before, and note was on that list. So it's completely valid XML to use note as a group name or a data element name, but it's not going to be helpful when we start importing it into Microsoft Access. So there's one more issue with this. If you haven't seen it yet, pause the video and try to think out what other issues could we have with these names. Okay, so I've renamed note to instructions, and the other issue is name up here and down there. So up here would be in patient, and we have name and medication. So there's actually two issues with this. The first one is it's not unique. We've repeated a name. So patient is using name, like the patient group has a data element named name, and the medication group has a data element named name. So that's not allowed. They have to be unique. The second issue is name is a reserved word in Access. So we're going to resolve this by changing patient name to patient name, and we're going to change the name and medication to medication name. So once again, you can see that medication name is repeating, but that's okay because that's in the same group. Each data element in the same group should have the same name if it's the same data being represented. The problem is when they're not unique across different groupings. So that's good. This is what we'd want. We'd actually have problems if we didn't keep using the same name in the same group. So the next step, and where we're going to actually start writing some XML, is to add the XML document identifier, that preprocessor tag. We saw that at the beginning, and that was this tag here, which just tells the computer that this is an XML document. So on some of the W3 School tutorials and some other resources, you might see a little more information put in this. Sometimes it has the encoding. For what we're doing, we really only need just the version number. The encoding just tells the computer sort of what text standards you're using. In most cases, we're just going to be using a plain text editor that's probably going to be using ASCII, so we don't need to add anything. We just have to have this at the top of our file. And remember, we can't have any spaces or lines before this. It has to be the first line in our file. So we'll put that at the top, and that'll be the top of our file. So the next step, which is going to take a while, and you have to be really careful when you're doing it, but we've really done all the work already, is going to be adding the tags to our XML document. What we're going to be doing is going through this from the top to bottom, and each time we encounter the start of a group, we're going to add a start tag for that group. Each time we can encounter a data element, that's going to be a simple element. We're going to surround it with a tag with the same name as the data element. And whenever we encounter at the end of a group, we're going to add an ending tag for that group. So groups are going to become complex elements, and data elements are going to become the simple elements. We'll start at the top here, and the first thing we encounter is that patient list group. So we add an element called patient list. So we keep going down. The next thing we're going to encounter is the patient group. So we add an element named patient. So it's pretty straightforward. It's just the same name. We're just wrapping it in brackets. And we want it to be on separate lines. That's not really a strict rule. It just makes the document easier to read. You also notice that I'm indenting things as we go in deeper into groups. I always space it out a little bit. That's not a strict rule. Your XML document will still work fine if you don't indent anything, but it hurts the readability of the document. So for your assignment, make sure that you are indenting your document wherever there's a grouping, just to make it easier to read, both for the TA and for yourself. So now the next thing we're going to hit is in a grouping. It's a data element, card number in this case. So we're going to start by adding the card number opening tag, the start tag, in front of card num on the same line. And then we have to have a matching closing tag on the other side. So we want to wrap the data element, and we don't want to add any extra spaces. So for example, we shouldn't have a space here. We don't want a space between that bracket and that one. We also don't want a space here between that B and that bracket here. The reason why is XML preserves the spacing. So once we imported that into Microsoft Access, there would be a space in our data here and a space over here. And that could cause problems later on when we're making queries and stuff, because there'll be spaces and stuff and our data won't be clean. So we want these tags to touch the data right on, no spaces in between, and no line breaks. So it has to be right touching it, just like that. So that's what it would look like when it's properly indented. And we're going to do the same thing for each one of these data elements as we come to it, top to bottom. So the next one's going to be patient name. We put an opening tag and a closing tag. And again, the closing tag always has that / at the beginning. And then hit phone number, address, and doctor ID. So we do the same for each one. We put an opening tag in front, closing tag behind, and where we're getting the names are just, these are just the names we picked for the data elements. So they become the element tag names. So the next thing we're going to hit here is medications. You can see from the arrow there, that means we're going to be starting our medication list. So this is a complex tag, so it's just going to be opening. I'll scroll up a little bit to make everything clearer. So medications is going to go right here.
And now you can see we are at that special case with last update. Last update is not really data so much as it is metadata. That is, data about other data. It tells us when the medication data was last updated. As I mentioned before, one way we can handle metadata is to encode it as an XML attribute in the tag it's related to. So in this case, last update can be an attribute for the medications element. Note that both simple and complex elements can have attributes, so it doesn't matter that medications is complex. Let's now see what this would look like. As you can see, we define an attribute by putting a space after the element name, and then we type the attribute's name. In this case, the name of the attribute is last update. We then give the attribute a value by typing an equal sign, and then giving the value in double quotations. We need the double quotations regardless if this value is a string, that's text, or a number. So any value that an attribute has to be in those quotes. Remember, we normally only use attributes for metadata, so we would not use this for something like a medication name or dosage, only metadata like the last update date.
So the next thing we're going to run into is the medication grouping. We're going to add the medication tag name, the opening one. And now we're going to go through each one of the data elements contained in medication. The medication name, dosage, instructions, and days. See all the opening tags, We're going to match them with closing tags and indent them properly. So these are all the values for that one medication. So you notice as we're going through, I'm removing some of the groupings, but I'm keeping the end tags. So we still have that where the end is going to be for medication. So it's important as you're doing this to keep track of where the end of the groups are too. And I'll show you why right now. So whenever we get to an ending of a group, we need to put an ending tag. So when we've reached the end of the group, we've reached where we need to put a closing tag for our complex element. In this case, we've got to the end of this one medication, so we're going to close it off with the closing medication tag. So each one of these can be seen as its own instance of a medication. So each one of these would be its own record when we get to a database. So we'll do the next one. So what we're doing just there is we're converting that amoxicillin medication record into a complete complex tag with the data elements. The way I did that was just the same process. Went down, each time I got to a data element, I wrote out a simple tag with that's name, and when we got to the end of the grouping, we wrote a closing tag for medication. So we're going to do the same thing for a medication that comes below it, and it's going to look, just zoom in a bit, just to make it a bit easier to see. So finally, we're at the end of the medication list. We have all our medications encoded as complex tags with simple tags in them. And now we have to close off the medication list. And we do that with a closing tag for medications. It has to match up here. We had an opening medications tag, so we needed a closing medications tag.
One thing you'll notice in this case is that the medications opening tag contains an attribute, last update. We don't repeat the attribute in the closing tag. Attributes are only placed in opening tags and never in closing tags. A very common mistake students can make when they're starting out with XML is repeating the attributes in the closing tag. Please don't do this because it's going to cause errors when you go to validate the document later.
And we can't forget about birth date on the end here. This birth date is just a simple tag, so it goes right in place like this. We surround it with the two tags with no spaces. And now we're at the end of the patient record, or the patient group, so we have to close off the patient tag. And one thing we can't forget about is if we were to zoom out a bit, there's also that patient list group. So we're going to fill that in right here. Patient list, that's going to be our root element. By root element, we mean the outermost element. So we can't have more than one outermost element in an XML document. That was one of the rules we saw at the beginning. So in this case, our root element is patient list because it contains everything else. Always be one element that contains everything and only one element that contains absolutely everything. Finally, we're done our XML document, or at least we've done it for one patient. Remember, we still have 2 more patient records. But before we go any further, there's a few things we should consider. Right now, this is an XML document, but our end goal here is going to be eventually to import this into our doctor's office Microsoft Access database. So there are a few extra considerations that you normally don't take with a normal XML document that we have to take when we're making one to be imported into Microsoft Access. And first, we're going to take a look at what's actually going to become tables and what's going to be the records once we import this. So the list of medications is going to eventually become the medications table. So each one of these things in this green box here is going to be a record in our medications table. So we'd have one for Advil, amoxicillin, and so on. So there'll be a second table, and that's going to be the patient table, which would contain all of the data for the patients, like the card name, the patient name, phone number, things like that. So in our patient table, what we're probably going to be using as a primary key is that card number, because it's the only thing that's guaranteed to be unique. Name, for example, we could have 2 patients with the same name. You could have 2 patients living at the same street or with the same phone number. So those aren't make good primary keys. The health card number is guaranteed to be unique, so that's going to become the primary key for our patient table. Medication table doesn't really need a primary key, but there is an issue. It's what is the foreign key going to be? Because remember, the goal here is to link the medications to the patients. So if we were to just import this into Access the way it is, we'd get 2 tables, a patient table, and we'd be fine with the primary key there, and we get a medication table. but we wouldn't get anything that links them together. So unfortunately, Microsoft Access isn't really smart enough to notice that these medications were listed inside the patient record, so it's not going to know to add its own foreign key. So we sort of have to do that work for Microsoft Access to tell it what the foreign key is. So this makes it a bit redundant, but it will help making it when we want to import it into Microsoft Access. So remember, if we want to link these to the patient record, the foreign key is going to have to be a copy of the primary key from the patient record. So in this case, that's going to be the health card number. The next step is going to be adding that foreign key to our data. Let's zoom in a bit, and we'll remember that up here, see, up here is our card number, so the health card number for this patient. So this is what's going to be our foreign key for the medications table. So in the medications table, we want to list each one of these medications as belonging to this patient, Joe Bloggs. To do that, we're going to have to sort of put a copy of that key into these medication records. That would look something like this. So in this case, I called it patient card number. Remember, the foreign key doesn't have to have the same name as the primary key, but it does have to have the same value when it's the record referencing it. So when it's an instance of it. So in this case, we're making sure that the value each time is the exact same as Joe Bloggs' health card number, because these are medications for Joe Bloggs. So this is what our document looks like right now. We have one patient in it, and we're stopping at this point before we add the other patients, because this is a good point to actually test our document to make sure it's valid. We don't want to put all the work in adding in the other patients if it's not going to be valid XML and there's a small error. Then we'd have to go back and repeat it multiple times. So I highly recommend when you're working on an XML document, after you've got that first big record in, that you validate it.
So how do we validate our XML document and ensure that our syntax is correct? Well, in this course, you have two options available to you. The first, and the one that we recommend the most, is to use Notepad++ with the XML tools plugins. This way, you'll have an XML validator built right into your editor, and you don't have to do any extra steps like uploading documents to a validation tool or anything like that. Notepad++ is available on Windows, but for Mac users, we also now have it available on My VLab with the XML tools plugin, so you can use that as an alternative. If for some reason that's not possible for you, there's also a website that we'll be showing you that you can upload your XML document to, and it will tell you if the syntax is valid. And that website is xmlvalidation.com. So it is important for assignments that you do ensure that all of the XML you're writing is valid, that is, that the syntax is correct. And these tools will tell us if it's correct or not, and it will help us find errors in our syntax. Let's cut to the desktop and see how that works. So the first thing we do, if we're using Notepad++, is open up Notepad++. And most of us, when we've just first installed Notepad++, it might not have the XML tools plugin installed. So the first thing we're going to do is install that. To do that, it's quite easy. You just go to Plugins. You go to Plugin Admin. And then right here in the search bar, you type in XML space tools. And you should see the option down here. It should say XML tools, and whatever the latest version should be fine. In this case, I'm 3.0.4.3, but as long as you have it, it should be good. You click the checkbox next to XML tools, and you click install. You click yes, you're going to do this. It's going to close Notepad++. Probably going to ask you if you're sure you want to run this program. And then Notepad++ will restart, and it looks about the same, except if you go into the plugins now, you'll see that we have this XML tools drop down. And this is going to have a few options that we're going to take a look at, like check the XML syntax and validate now. So the next step would be to actually type out your XML document by hand. So most of the work you're going to be doing is going to be in Notepad++, looking back between your data and how you want to represent it, and then typing it out in Notepad++. So like we showed in the tutorial slides a few minutes ago, you want to start with just one entity, like one instance of an entity to start with, just to sort of test it out. So in this case, I'm going to make the text appear rather than make you watch me type it out. So 1, 2, 3. So all the text should be there now, right behind me in Notepad++. And there's a few interesting things here.
So the first thing you might notice is this highlighting. So Notepad++, if we've saved this document as .xml, that's one of the first things we should do when we start typing in our document. Make sure that it ends in the .xml extension and that we've saved it. It's going to detect that it's an XML file, and it's going to actually start highlighting the syntax for us. This just makes it a little bit easier to see where certain elements start, if the element's complex or not, or if this is literal text. So you can see here as you go click on the different parts, it highlights where the start of the tag is, where the end of the tag is, things like that, just to make your life a little bit easier. So it's important to note that just because you have the syntax highlighting doesn't mean the syntax is correct. To check that, we have to use that plugin that we installed. So it's quite easy if you're using Notepad++ with the XML tools. All you do, if you want to check if the syntax that we typed in is correct, you just go to Plugins, XML Tools, and you click Check XML Syntax Now. You can see that I got no errors detected popped up. That's a good sign. So that's letting us know that just the XML syntax is correct. It doesn't mean that it's logically correct, like we could have gibberish in here, like instead of a name, we could just have like Western or cat. Doesn't mean that the data makes sense. It also doesn't mean that this accurately represents what we're trying to represent. All it's saying is that the XML syntax that we've provided doesn't violate any of the XML rules. And that's a great start, but as we'll see later on in the schema tutorial, there are more steps we have to take to make sure that this is a fully validated XML document. But for just checking the syntax, it's a great step. So let's see what happens if something goes wrong. I'm going to open up a file open. And this is very similar to the file we just saw, except there's a few small errors in it that I've intentionally added. So if you're very keen looking at the document behind me, you might be able to see a few of them, but we're going to do the XML checking again, just to show how this tool can help us find the errors if we're not sure. So I'll go to validate it again. We go Plugins, XML Tools, check Syntax Now. And you can see that this big thing popped up here and said XML parsing error. Line 8, position 19, and then it says end tag doctor ID does not match start tag physician ID. So this gives us a pretty good idea where the problem is in our file. It might not always be exactly where it shows. Sometimes it could be something a little bit before this caused it, but it is a pretty good hint that it's going to be around line 8 right here. And then the message is giving us saying that the end tag doctor ID doesn't match the start tag physician ID is explaining what the error is. So in this case, it's pretty straightforward. It's saying that this start tag here, physician ID, doesn't match the end tag here, doctor ID. So to fix that, that's easy enough. We just change doctor to physician. And Notepad++ has this nice drop-down menu for us, so we could just select it. It has a lot of autocomplete stuff. Though it's not always perfect, you can see here that it added 2 IDs. And a good indication that we have a matching tag is that it now highlights them both. So you notice the error doesn't automatically disappear. Instead, we have to revalidate the file. So every time we think we fixed an error or made a change, we have to revalidate over and over again. Go back to Plugins, XML Tools, check the syntax again. And you can see the error up here is gone, but it found a second error in this file. In this case, it's saying the error is happening around here, around line 23, and it's saying medication tag does not match the start tag dosage. That might seem a little bit confusing when we're just looking at it quickly, because we see we have medication tag up here and medication tag down here. Not like that last error that we saw where the tag didn't have the right ending tag. In this case, it's something else that's causing it. So this is a great example of where the error message you get might not be 100% clear. So really you should reread above the lines right above the error and see if there's something that could be in there that's causing this. So one thing you could do is pause the video right now, take a look at this, and see if you can spot where the error is. Once you think you have an idea, unpause, and we'll take a look. Okay, so we're going to take a look at the solution. In this case, we can see that dosages here, this element, doesn't have a closing tag. So we have an opening dosage tag, but we don't have the matching closing one. And this is causing an error because it thinks that it's including all this, and then it eventually runs into a tag that's in the wrong spot. So we get an error about medication, even though this error is actually about dosage. So this is what I mean when I say that it gives you a hint at where the error is. It's not always going to be 100% correct in the error message. It isn't always going to be exactly the line right above it. You have to put a little bit of critical thinking into it. You can't just blindly follow the error message. To fix this, we're going to say end dosage. And then we revalidate again. Plugins, XML tools, check XML syntax. And we can see that error has been resolved, but now there's yet another error that we have to fix. In this case, we're saying it's around line 33, that patient does not match the start tag patient. So this one seems a bit off. I mean, we have the word patient down here, we have the word patient up here, and it's even matching them. You see they're both being highlighted in purple here. So what's going on here? Remember, there is a rule about XML that is really important in this case. So pause the video, think about it a bit. If you think you have the answer, hit unpause. So now we're going to take a look at how you can use xmlvalidation.com, that website I mentioned earlier, to validate your XML document. This is only for those of you not using Notepad++, or who can't use the XML tools plugin in Notepad++. Otherwise, you can just validate using that plugin, and there's no need to use this website at all. So if you're using like brackets on Mac, you'd have to do this. But if you have Notepad++ on Windows, you could just do what we just did. So if you have Notepad++ with the XML tools, then you can skip to this timestamp right over here and continue with the slides. This next part's only for those using brackets or something like that. So after we have our document typed up like this, and we've saved it, in this case I saved it as patient list, one record, because this is just the version with one record. We're eventually going to have to put in more records. You have that saved that on your computer. So right now I have it in my desktop. Then we can go to our browser, type in http www.xmlvalidation.com, hit enter, and it will load up this site. So this site, basically we can upload our XML document to it, and it'll tell us if there's errors in it. So by errors, I mostly mean syntax errors. So it's not going to tell us if the data is wrong. So for example, if I typed Joe Blogg's phone number wrong, or if I had a spelling error in his name, it's not going to tell us anything like that. It's only going to tell us if there's errors in the actual syntax for XML. It's also not going to find errors like we called it instead of card number, we called it card like letter. It wouldn't detect that as long as we use it correctly. So it's not going to detect logic errors. It's also not going to detect errors like if we structured our document incorrectly but still used correct syntax. So it is important to follow the directions in your assignments and look over your own documents manually with your own eyes just to make sure they make sense. So there's two ways we can use this site. We can either paste our XML document in here, or we can upload it. So in this case, we're going to upload it. So I'm going to use the button upload, and it's on my desktop. So I'm going to go down, and it's patient list onerec.xml. And in this case, since we're only validating the XML document, we're not going to highlight this button. We're just going to click validate. And you can see we got a response saying no errors found in the document. So that means there's no XML syntax errors. We can look at a case, what would happen if there were errors now. So on OWL, there should be a file called, I believe, let's open it up. The file's name would be patient list onerec with errors. So it's a copy of what we just did, but I intentionally added a few errors to it. So we're going to see what happens when we try to validate something with an error in it. So first thing we'll take a look at is going to be how we have patient here, the word patient. You'll notice that down here we have the word patient again, but there's something a little bit off here with these two tags. It actually violates one of our rules that we talked about. So let's see what happens when we try to validate it. Once you want to validate a document again, I recommend just retyping in the ULR and not hitting back, because if you hit back on this, it can sometimes get a bit confused and you won't get accurate results. So make sure when you want to validate the document again, just type in the address again. In this case, we'll try pasting it in instead of uploading it. And a copy of this file is on OWL. So if you wanted to do a little practice problem, you could take a look at this XML and try to fix the errors, and then play the video and see if you got them right, or you found all the errors. So I'll paste it in here. We'll hit validate. And now instead of saying no errors found, it says an error has been found, and it gives us a bit of a description. And it also tells us the line number that's affected. So this isn't always 100% accurate, but it does give us a good guess of what's wrong. So the error here is element type physician ID must be terminated by a matching end tag physician ID. So I mentioned there was an issue with patient, but this actually found a different error. So it doesn't always find the errors in order of the XML document. So if you have multiple errors, it might only find one at a time. So let's take a look at line 8 and see what's going on. So you can click this little button and I'll jump down to that line. You can see in the document, let's take a look at it over here. It's a little bit easier to see. So it said, I believe, line number 8. So it can help to look at it in your own editor. Here's line 8. We can see it over on the sides. It's line 8. And there's something wrong with this line. And if you look at it, you can probably guess right away what's going on here. So the opening tag says physician ID, but the closing tag says doctor ID. That's a problem because they don't match. So that means physician ID isn't being closed and doctor ID isn't being opened. On the site, you can see that the error it gave sort of gives us a hint at that. It says physician ID must be terminated by a matching end tag. So what it's saying is that physician ID tag on line 8 was never closed. It doesn't have a matching end tag. So it's not smart enough to tell us that we do have an end tag, it's just named wrong. It's just smart enough to tell us that there isn't a matching end tag. So a lot of times you have to sort of interpret what this is telling you. So this site does allow us to edit and fix the error right on the site if we click XML document, but usually you'll want to do this in your actual file as well, because it's not going to save it on the site. In this case, we're going to change physician ID to doctor ID and see if we can find more errors. Maybe it'll get the one about patient ID this time, or patient tag. So hit validate again. And now it's found a new error. So it doesn't always list all the errors it finds at once. So it is important to keep revalidating it until you get that message saying that there's no errors. So in this case, it's not that patient error, it's actually a third error that's in the file about the element dosage. And it says that it's on line 23, and it's giving a similar error saying that it must be terminated by a matching end tag dosage. So we'll click on this button and we'll jump down to dosage, or in this case, it's medication. The reason why it's taking us to medication, and dosage actually starts up here, is that this is where it detected the error, because it got to the end of a grouping without the tag being closed. So these line numbers it gives you aren't always the exact line where the error is, they're sort of like an approximate location. In this case, it brought us down to 23, but the error is actually a bit higher up. So it's on line 19 in this case. Maybe you can see it even from there. We'll take a look in the file too. Go to line 19. You can see we have dosage being opened here, but there's no matching end tag. So that's a problem. So this is a different way that we could have no matching end tag, where the tag just doesn't exist at all, instead of there being a typo or being named wrong. We'll edit the document again. We find the line, and we're going to add in that closing tag. So finally, we're going to validate it again and see what happens. So again, we get an error, and this time it's talking about that patient error that we saw, or I mentioned at the beginning. So again, like I said before, it's not always in order of the errors occur. It can sometimes be in any order it determines. That's why you have to keep revalidating until you get no errors. So this type, it says, again, the patient element must be matched by a matching end tag. In this case, we see that patient opens here. That's one of our big groupings. We jump down to the end. We see we do have a patient tag, but there's something wrong. So if you recall from the list of rules, one of them was that tag names are case sensitive, meaning capitalization matters. So in this case, we have a capital P, but in this case down here, we have a lowercase p. So that's a problem because it considers those to be two different tags. So let's finally try validating. All the errors should be fixed now. And we finally get no errors were found. So this is what we want to see. So at this point, we know at least that this XML document has no XML syntax errors. Well, that's a good sign that we can now progress to adding more patients to our XML document. So let's switch back to the slides. So at this point, we know that our XML is valid, but we only have a single patient in the record. We want to add the remaining records to our XML document. So I'm going to scroll up a little bit and zoom in. And now we're looking at the very end of our XML document. You can see at the end of the patient list tag there, which is our root element. So we're going to want to add our remaining records in here, right below the last patient record and before the patient list. Remember, the patient list contains absolutely everything. In our case, that means it just has instances of patient. So we have a few patient complex tags inside there. So we're going to want to add the remaining patients, just like we did with the first one. And each one is going to be a record wrapped inside of a patient tag inside this document here. So this is the data for the next patient. We don't have any XML on it yet. So we would go through the same process, use the same groupings as before. So you don't have to come up with your own names again, or you don't have to come up with the groupings again, because the data should repeat itself. It should have the same groupings, it should have the same data elements, with just a few minor differences, mostly the values. So again, we have the same patient grouping, we have the same medication list grouping, and we have the same medication grouping. The one thing to point out here, though, is this record doesn't have a phone number. So it is possible that you could have optional data elements in your records. In the case of phone number here, we're just not going to enter anything. Usually when you have a record that's optional or a data element that's optional, we just don't add it. So we don't add a blank one. We don't add a phone number tag with nothing inside of it. What we do is we just omit that tag completely. What this will look like when we actually convert it into XML, you can see that we have the patient name and the patient address, but phone number's not there. So it would be, I think, somewhere around here where the phone number would be, but since this patient doesn't have a phone number, we just simply omit that completely. And the way we got this XML was the exact same process we saw before, using the same group names, same data element names. We went from the top of the record to the bottom, and we converted each one into XML by just using that group name in the tag or using that data element name in the tag. We always make sure when we get to the end of a grouping that we end in a closing tag for that complex tag for that group. So here, this patient only had 2 medications, and we'll see that sometimes when we look at the records, they'll have like different number of records underneath them. So this patient only had 2 medications. The next one we're going to look at only has 1 medication. And in some cases in real life, we probably have patients that have no medications. So that's perfectly fine. We're going to scroll up again to see where we can add the next patient record. So we're at the end of our document again. We basically just add in that patient, scrolled up. So we're going to add in the next record right here at the end again, and we just keep repeating this process, however many records we had to add to our XML document. Keep converting them to XML and adding them in the list. In this case, this will be the last one. Here's the data. In this case, it's Patty O'Brien, and they have a single medication, but they do have a phone number. So we'd follow the same process, use the same groupings, start at the top, go to the bottom. Each time a grouping starts, we add a start tag for that complex element. Each time we get to a data element, we wrap it in the simple element tags. So this is what that would look like. Just the one medication, we do have the phone number, and it pretty much looks the same as the other cases. So there is something a little bit different about this record that we're going to have to get into. So the question is, are we done yet? So it looks like we have all the patients, we have all the XML in. So are there any more steps? And like I alluded to, there is something special about this patient's record. And that is these characters here. So the apostrophe in O'Brien and that ampersand in once daily and as needed. So we could just remove these, or we could replace like the and% with the word and, but we want to import this data as authentically as possible. We don't want to try to interpret the doctor's instructions at all, for instance, and the patient might not like it if we start editing their name. So these symbols have a little bit of a problem, and that's because they mean things in XML. And that's going to be a problem because XML will think that we're trying to do something in terms of syntax when we're actually trying to encode data. So we need a way to tell XML that this is meant literally. We mean this literal character, and we don't mean to do something special. So we need a way to escape this data. Now, if some of you are familiar with programming languages or a few other things that escape data, they usually escape it with a slash in front. We saw that in Access for the input mask. That's not the case in XML. We have to do something a little special. We have to replace those special characters with that something. And that comes from this table here. So this table has the few characters we have to worry about. And there aren't too many, so it's not that big of a problem. It's ampersand, the less than sign, the greater than sign, the double quote, and the apostrophe. So to replace these, XML gives us some special words to represent them. So for the ampersand, or the and symbol, we have this code right here. So it starts with an ampersand, AMP, and then a semicolon. For less than, we have a similar word, greater than, quotes, and apostrophe. So the way this works is whenever we see an apostrophe in our actual data, not necessarily in the XML document, because it could be used for something valid in the syntax rather than the data, but whenever we see any of these characters in our raw data, we have to replace them. So when we see the ampersand, we'll replace it with this code right here. And when we see the apostrophe, we replace it with this code right here, exactly as it is. And we don't want to add spaces on either side unless there are spaces in the data. So you can see I've done that here. I've also made it big. And you can see in this case, I don't add an extra space because there wasn't a space there in the data. If we added spaces on either side of this, it would put spaces in the data. So the name would be O space apostrophe space Brian. And we don't want that. The other way, down here, there were spaces in the data, so we want to keep those spaces. We want to say the word day, space, the and symbol, and then a space. So what will happen is, once this is imported into something like Microsoft Access, it's going to replace these characters for us with the actual symbol they represent. So once we see this in an actual record in our database, it won't be this weird code, it will be the actual and symbol, or the ampersand symbol. Same thing with the apostrophe. So that's an important step, otherwise we might get some errors when we try to validate this XML document, and we won't be able to import it correctly. So now I've just sort of made those normal size. And this is the complete patient record now. So we're going to scroll back all the way up to the top. So we have our complete XML document here now. And it's a bit long to fit on one screen, but I do have a copy of this on OWL if you take a look at it. So one last thing we should do is, this is fine. We have all our data in, we have our XML. We're going to have to validate it, but we think that it's valid. But we should also document this. So we might come back to this document in a few years, and we might not know what card num is, for example, or we might not even know why we created this document in the first place. So we want to add documentation and comments. So this is the same idea as the sort of comment or the documentation field in the Access database, where we had to put in notes to give us a hint at what this actual field was. So the same idea applies to XML, except we have a very different way of adding those comments and documentation to our files. And that's with another preprocessor directive. In this case, it starts with an exclamation mark followed by 2 dashes, and it ends with 2 dashes and an ending tag, or a closing bracket, rather. What this does is it just says that this is a comment. It's going to be completely ignored by the computer. It's only for humans. We call this a preprocessor directive because when the computer first looks at it, it's just going to remove all these comments. It's not even going to pay attention to them. So they have no effect on our data. They have no effect on anything except for what we see in the file. So it's a great way to document your file. So in this case, I put a comment at the beginning saying what this file is and why I'm making it. I want to import this into my doctor office database. So for your assignment, you do have to document it slightly. You have to put in your sort of name, your student number, and stuff like that. So a comment is probably the ideal way to do that. You see them on their own lines here, but comments can also be on the same line as data. So we can see we wanted to say what card number was, so I added it on the end here in a comment. So we shouldn't put the comments inside of the tags, that could get a bit confusing, but it's fine to put them on the end here. I've posted a copy of this XML document on OWL, so you don't have to worry about copying this from the slides. You can download the actual XML document from OWL. So the last step, at least for writing the XML, is to validate once we have all the records in. So it's a good practice to validate first with one record, then validate as you're adding each record as you go. You want to keep validating just to make sure you haven't introduced any errors in the process. So in this case, we'll show validating the syntax and sort of the last step for the XML. It's not the last step overall. We do have to worry about schema, which is in our next video, but we'll show how to validate the whole XML document. It's going to be just like we did it for one record. So I'll switch over to the desktop. So up behind me, I have that document that we saw in those slides, exactly the same, except it's now in Notepad++, and you can see that we have this nice syntax highlighting. So it's important to note that this highlighting isn't like part of the document. There's nothing in the document that says this line's blue. We opened it in a different text editor, it could be a different color. All this is Notepad++ giving us a little bit of feedback just to make it easier to read the document. So once again, there is no bold, there's no colors in XML documents, what we call a flat file, or a plain text file, meaning that there's no formatting, just text. What we're seeing here is what we call syntax highlighting, and it's just sort of a visual aid to make us really easy to separate tags from data, and we can see attributes, things like that, all in different colors. And we also get that nice highlighting to tell us where a tag begins and a tag ends. So if you're using the XML Tools plugin, this validation is going to be very easy. I've already showed how you install the plugin. So all you do, assuming you have it already installed and your documents in here, you go Plugins, XML Tools, and you click the check XML syntax now. In this case, we have no errors, so that means we know the XML syntax is valid. Once again, that doesn't mean your data is correct. You could have data that doesn't make sense. It also doesn't mean necessarily that the structure of your document is correct in terms of what you're trying to do. It just means that we follow the XML syntax rules. In our next tutorial, we're going to be taking a look at how to enforce more of the rules so that it has to actually follow what we're trying to do. It has to follow the data model of our database. We'll do that with XSD or XML schema. That's another name for it. So in the next part, I'll show how to do this again with that XML validation website. But if you're using the XML Tools plugin, you can just skip to the end of the video. I'll put timestamp for that right over here. So if you're still with us, I assume that you're now going to be looking at how to use this with xmlvalidation.com. So once again, we don't recommend using the xmlvalidation.com website if you can avoid it. It's so much easier to use the Notepad++'s built-in tools, our XML tools, just because you can check right here. Just go plugin, check. You don't have to worry about uploading it to this website and all that. If you can use Notepad++, you absolutely can't. For example, if you're on Mac OS and you can't use MyVLab for some reason, then you can follow these steps. But do remember that even if you're on Mac OS, MyVLab does have Notepad++ installed, so you can always use that. And there are some tutorials on how to do that in the Course Resources tab. Now we're going to use the same document, and we're going to try it with the XML validation website. In this case, we are going to use the same site again. Type in the address. I'm going to browse for the file. In this case, I have it on my desktop, and I saved it as patientlist.allrec.xml. It could be named whatever you want. There's no rules for how you have to name your actual file, just that it has to end in .xml. So again, we're just going to click validate. We're not going to check this box yet. We'll get to that in the next tutorial. And no errors were found. So that's good. It means that it's at least following the XML syntax, and that we can move on to the next tutorial, which is going to be writing a schema for this. So what's a schema? It's sort of a way to enforce the rules in our document. So right now we sort of have a format or a blueprint we've made, what certain groups are called certain things, certain data elements are called certain things, certain data elements belong to certain groups. Right now, when we validate that XML document, it's not checking any of that. It's just checking if the XML syntax is valid. So if we wanted someone else to make these documents, maybe we had an intern and we told them to make a bunch of XML documents following our standard, we'd want a way to check those documents to see if the intern wrote them correctly. So schema allows us to specify a blueprint that will allow us to check to see if a XML document conforms to our blueprint. So next tutorial, we'll be covering that. So if you're still up for it, give it a watch now. Otherwise, make sure you watch it before you start in on assignment. So thank you for watching and have a great day.